Good day, grade 10s. Welcome to our new review unit, which is the review of exponent and power laws. So exponent and power laws are using, just like it says, exponents. However, we have things happening with exponents. 2 squared times 2 cubed, something you were introduced to in junior high. Well, we can solve it, but we can also simplify it using power laws. Maybe you already look at that and say, hey, you know what? That can become 2 exponent 5. That's a great start. This is a review unit. Going to go through it fairly quickly. A little bit of new information in the second set of lessons, but this first set, it's all review. So we'll go through it quickly. Make sure you're on top of it and make sure you practice it, because this is all information that's going to be very beneficial moving forward in your math courses. So keep in mind, what we're looking at is we in high school start to work a lot with variables. We get away from just having numbers in the math, and now we extend it. Last year, you might have seen this question with numeric bases. It's the same idea, but now instead of working with numbers for bases, we're going to start working with a lot of variables. So obviously, we could get a final answer number for this, but in this top question, we can't get a number answer because there's no numbers to work with in the bases. So we're going to be able to simplify it and come up with a power, a new power that's a exponent something. That's what you're looking at doing with the exponent laws. So let's get into it. But before we actually start working with the exponent laws, let's refresh our memory as to exactly what powers are and how we can calculate it. So page 2 of the booklet. Powers, first of all, this entire thing, the 5 exponent 3 altogether, that's a power. An exponent base combination. So we're going to look at what do we do when we have multiple powers and certain math operations happening with them. The 5, the big number, that's the base. That's the number we multiply by itself. So for this question, we're going to have to multiply 5 a number of times. How many times? Well, that's what the little number tells us, the exponent. The exponent is telling us how many times, the number of times the base is a factor. How many times do we have a 5? That's what this is looking at. So 5 exponent 3 tells us that our 5 is going to multiply by itself. The 3 tells us, the exponent, we need 5 as a factor 3 times. So 5 times 5 times 5. Please note it's not 15. It's not. And this is so common. Students will go 5 times 3. No, no, no. It's 5 as a factor 3 times. 5 times 5 is 25. 25 times another 5 is 125. That's how we calculate powers. So, very quickly, pause the video, give these 5 a try. I'm going to add one in a second, but give those 5 a try. Let's see what you end up with. Then come back and we'll do it together. All right, so hopefully 3 exponent 3, you have a 3 as the base, so that's what you're going to multiply as a factor 3 times. 3 times 3 times 3, 3 times 3 is 9, times 3 is 27. 2 to the 5, 2 is the base, that's what you're multiplying by itself. The 5 is how many times it's a factor. So 2 times 2 is twice, 3, 4, 5 times. The base 2 has to be a factor 5 times. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 1 to the 56. Love this question. So many people think it's going to be a 56, but it's not, because we have 1 times 1 times 1 times 1. The base is 1. That's what's being multiplied over and over. We need it 56 times. Well, I'm not going to do it 56 times, because if I go 1 times 1, it's 1. Times 1 is 1. Times 1 is 1. Times 1 is 1. So it's just a 1. So careful with something like that. 7 exponent 2, also called 7 squared. 7 is the base. It needs to be a factor, not times 2. It needs to be a factor twice. So 7 times 7, 49. And the last one here right now, 5 to the 7. Well, 5 is our base, and we want to have it as a factor 7 times. So I need 1, 2, 3, 4, 5, 6, 7 5s, because that's what my exponent is. Now, very quickly, on your calculator, if I pull up my calculator, there's a button here, a little arrow you see pointing up. That, on a graphing calculator, which is the TI which we're hoping you have for this course, is the button that tells you to go to an exponent. If I hit my base 5 and then I hit that little arrow button going up, you can see that it goes up to an exponent. And then I can hit my 7, but be careful, because the cursor is still showing that it is in the exponent position. So make sure you use your little arrow cursor key, bump it over so it's not there anymore. So it's that little arrow up key that tells you that's what you can push to get a exponent. And then I hit enter, 78,125. Now, some of you that don't have a graphing calculator yet, your calculator might have a button on it like that. And that's the same thing as that button. You would hit 5, this button, and then 7, and it should pop up as 78,125. So you don't have to, on your calculator, go 5 times 5 times 5 times 5 times 5 times 5. You can use the power buttons on them. So keep that in mind. It will be useful at times. So again, this one was 78,125. Now, an example that's not on here that can be useful and something you should be familiar with, if we had 4 to the 5, all of that to the exponent 3. Well, in this case, our base is a fraction, and there is no difference in how we approach it. Base is 4/5. That's what we multiply by itself, and we need it as a factor 3 times. 4 to the 5th times 4 to the 5th times 4 to the 5th. Multiply fractions. 4 times 4 times 4, 64. 5 times 5 times 5, 125. So there's our solution. Even though your base is a fraction, it doesn't change anything. So straightforward, hopefully. Here's where it started to get a little bit confusing in earlier courses, is the idea when you have an integer base. Bases aren't always positive. What's important is to know, what is the base? Is the negative or is not the negative part of the base? And how I always think of it, the base is directly left of the exponent. So in this first one, 2 to the 4, I'm just going to write it a little bigger so it's easier for me to work with. What's directly to the left of the exponent 4? The 2. So the 2 is the base. 2 times 2 times 2 times 2. Seen that before. Negative 2 to the 4. Here's where you have to start thinking a bit. What's directly to the left of the exponent 4? Well, directly left of the 4 is just the 2. That's the first thing we come across. This negative isn't part of the base. So the negative just stays out front. If the negative is not part of the base, keep it out front. So you can see in our calculation down here, the 2 is not part, or the 2 is the base, the negative's not. So we just write the negative out front. And this is like saying you have a negative 2 times 2 times 2 times 2. And the negative stays in your answer. Negative 16. Know what the base is. How that differs from this next one, negative 2 in brackets to the 4. Well, this time when you say what's directly to the left of the exponent 4, well, the first thing we come across is the bracket. So that's now saying everything in the bracket is your base. So we have to have all of negative 2 being multiplied. And that's what we've done. In this second example, directly beside the 4 was just the 2. Now, in this example, beside the 4 is the bracket. So everything in bracket is your base. So negative 2 times negative 2 times negative 2 times negative 2. This time, the negative's part of it. So we need a negative in every calculation. 2 times 2 times 2 times 2 is 16. 4 negatives make a positive. So you have to be careful with negative bases. Pause the video, give these a try, and then we'll take a look at them together. So what we're looking at here, this first one, directly beside the 3 is a bracket, so everything in the bracket is your base. So negative 3 needs to multiply by itself, and it has to occur 3 times. 3 times 3 times 3 is 27. 3 negatives, odd number of negatives makes a negative. The next one, directly beside the 2 is just the 6. The negative's not part of the base. The 6 is the base, so the negative stays out front, and you have a negative 6 times 6, which means it's a negative 36. Negative 1 to the 24. I'm not going to write this one out a whole bunch of times, but what we're looking at, directly beside the 24 is the bracket. So everything in the bracket is the base. Negative 1 times negative 1 times negative 1. We need to do it 24 times. Well, 1 times 1 times 1 times 1 times 1, it's going to be a 1. And if you have 24 negatives, even number of negatives leaves it as a positive. So we get a positive 1. Is that going to be different than on the one underneath? Well, in this case, directly beside the exponent 24 is just the 1. So 1 is the base, negative stays out front. So we end up with a negative 1 times 1 times 1 times 1 times 1 times 1 times 1, which means the negative out front is going to leave it as a negative 1. Know what the base is. Second column up here, negative 2 squared, no bracket, so the negative stays out front. Negative 2 times 2, which means it's a negative 4. And the last one, negative 5 in brackets, squared, directly beside the 2 is a bracket, so everything in the bracket is the base, which is negative 5, and the exponent tells us it's a factor twice. Negative 5 times negative 5 is positive 25. So, important, this is not new. This goes back to grade 8 in junior high when this was first introduced. But you need to practice it. Powers with exponent 0. Basically here, anything where the exponent is 0 gives you a value of 1, not 0. You'll see in a couple minutes why. 12 exponent 0 is 1. Negative 4 exponent 0, what's directly beside the exponent 0? A bracket. So negative 4 to the 0, anything exponent 0 is 1. This last one, a little trickier. Because in this case, what's the base for the 0? Just to 6. So 6 to the 0, anything exponent 0 is 1. But the negative's out front by itself because there's no bracket. We need to make sure we include it. So it's a negative in this case because the 6 exponent 0 is the power, negative out front. Here, the negative 4 was the base, so the whole thing was the power. Any base exponent 0 is 1. Keep that in mind. That's a little point. It's been told to you and ingrained in your brain, but you need to now remember it. Last little bit with this lesson is powers with negative exponents. Now, this is something that you have not seen before, or maybe it was introduced to you, but it's going to be so important in the grade 10 program and moving forward. Negative exponents are unique. The first thing, a negative exponent does not make the product negative. Just because you see a negative exponent doesn't mean it's negative. I'm going to show you in this box what happens. 3 cubed, we should now know is 27. 3 squared, 3 times 3 is 9. 3 to the 1, 3 times 1 is 3. 3 to the 0, we just talked about it. Anything exponent 0 is 1. And now we get to the negatives. Well, math is about patterns. So I see that as I decrease my exponents by 1, well, I'm just dividing each value by 3 to get to the next one. 3 cubed was 27, 3 squared was 9. Well, I'm dividing by 3 because there's 1 less 3 in it. And I divide by 3. So to go from 3 to the 1 to 3 to the 0, I still divide by 3, and we see there's the reason 3 to the 0 is 1. It follows the pattern. But now we need to go to the negative exponents. The pattern doesn't change. All I want to do is divide by 3. So what's 1 divided by 3? Well, 1 divided by 3 is an ugly decimal, but look at this. When I write 1 divided by 3 as a fraction, there's what 3 exponent negative 1 equals, 1/3. How do I get from 3 to the negative 1 to 3 to the negative 2? I divide by 3. Well, if I have 1/3 and I divide by 3, remember with fractions we don't divide, we multiply by the reciprocals, so we get 1/9. And if you take a look at this, really 3 exponent negative 1 is really just saying, hey, 3 exponent 1 is 3. Let's put it in the denominator and leave a 1 up top. 3 squared, 3 times 3 is 9. When it's a negative 2, let's put the 9 on the bottom and leave the 1 up top. So the rule is negative exponents. It's not a negative answer. It tells you the base has to be reciprocated. And that's the key rule. 5 over negative 2 becomes, well, if I start with 5, I can think of it as 5 over 1. The negative exponent tells me to reciprocate the base. Flip my 1 and 5, and all of a sudden, my exponent's now positive. So we reciprocate the base, and we flip the sign to positive. And now we have 1/5 times 1/5, which is 1/25. a negative exponent doesn't mean it's a negative answer. It tells you to reciprocate your base. So just to write it a little bit bigger, 2 to the negative 4. Oh, wait a sec, negative exponent. My base right now is 2, or 2 over 1. Negative exponent tells me to flip my base, and my negative exponent now becomes a positive exponent for the base 1/2. So 2 to the negative 4, flip the base, exponent becomes positive, and now we have 1/2 times 1/2 times 1/2. My base occurs 4 times as a factor, 1 over 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. Reciprocate your base, and then you get a positive exponent. 2 over 3 to the negative 2. Negative exponent. Notice that. Negative exponent means what? The base needs to flip. So my 2/3 base needs to become a 3/2. And because I reciprocated the base, what happens? My negative exponent becomes a positive exponent. So again, negative exponent, 2/3 reciprocates to become 3 over 2, and the negative exponent becomes a positive exponent. And now we can evaluate that because working with a positive exponent is something we've done. 3/2 times 3/2, 3 times 3 is 9, 2 times 2 is 4, 9/4. Now the last one, number 7, it looks ugly because it's a decimal, but anytime you get a question like this, the decimal, 0.25, you should know that as a fraction. Now you could put it as 25 over 100 because it's 25 hundredths, but 0.25, that can simplify to 1/4. So instead of working with the decimal base, let's work with the fraction base. So instead of 0.25 to the negative 3, I've converted it to 1 over 4 to the negative 3, because fractions are going to be easier to work with. But it's a negative exponent. What does that tell me to do? Negative exponent, reciprocate my base. The reciprocal of 1 over 4 is now 4 over 1. 4 over 1, though, is really just 4. And because I reciprocated the base, my negative exponent is now a positive exponent. So this is just 4 exponent 3, which is 64. So, little review of powers, little bit new information. This negative exponent, there's not a lot to it, but you need to learn to recognize. Wait a sec, negative exponent, reciprocate the base. Negative exponent, get the reciprocal of the base. Negative exponent, get the reciprocal of the base. That's what you need to look to do. Your assignment, please, in the booklet, page 10, numbers 1, 2, and 3. And in 3, you can omit I. In number 3, you can omit I. It's a little goofy. But that is what you're looking to do. Quick little calculations, but practice it so that you learn to recognize the negative exponents especially. The only way to get good at it is practice it. Have fun.